Okay, after making some plots, there are a few other topics in the lab that we're going to not go through in the interest of time. And you can see, if you ever want to know the sub-parts of the lab, you can use this sort of table of contents tab here. So we have some examples about how to access data in arrays and how to use slices in general for sequences in Python. That is important, but I think more important is to talk about data frames. So we're going to jump here to this loading data part of the lab. Okay, so we've talked now about NumPy arrays, which are representations of numbers in the computer. There are lots of ways to represent data in a computer. Not all data is numeric, and so there's an object that's something like an array or a matrix, but it's called a data frame. That is sort of familiar in many languages for data analysis. So the library that implements data frames in Python is the pandas library, or that's the default library. So if you have a data file, here this is a so-called CSV file, we can read it in using pandas. And if you want, we can take a quick look at the data file. So here's the auto data file, and I'm going to open it up so we can see what it looks like. And it's in a file. The first row is the column names, and then the data is separated by columns.
I see. So there's numbers as well as categorical.
Yeah, these names here. This is the name of this is a file about different models of cars. I think it's from the late 70s or 80s, and has some measurements on each model of car. So you can see that you need something in a computer to represent the model of car. It's different than an MPG. An MPG is a decimal number, right? But
so some columns will be numbers and some will be character vectors.
Yes, that's the big distinction between a data frame and an array.
Yeah.
Is an array, all the entries kind of have to be the same type. A data frame, they can be different types. Yeah. Okay, so these files here, I've copied them from the data directory. If you go back, this is the directory we were on the desktop. In the data directory there, the auto files, I've just copied them back into this Jupyter notebook file so that the computer knows where to find them. Okay. Let's go back to where we were, and let's get rid of the sidebar. Okay. Okay, so we're going to read in the file, and let's take a look at the data frame. Well, we see it has these columns. That's the first row of the data file we saw, and we see these. It has recognized that the name column were strings, and some columns were floats. Here it has a decimal for the acceleration, so it recognized that should be treated as a float, and that should be treated as a string.
I think this example also shows, Jonathan, that a CSV file is a good format for input in data because it's got the column names and you just had to read it in and everything was preserved. Yeah.
Yes. CSV is a very common format for tabular data that we can think of as having, where the rows are each corresponding a different car here or a different person, and the columns are different measurements on each of the row variables.
Yeah, that makes it nice and easy.
Yeah. Okay. There's another version of the file. Let's move on from that. So we can access columns by using the same sort of square bracket notation we saw for arrays, but here we can give a column name. So auto horsepower is going to be those numbers we saw in the horsepower column above. There's a comment in the lab here that says this should be an object data type. That's because I skipped a line. Here, let's just do that. Just to be honest, the reason this is not recognized as float, and that's because there are some missing values represented by question marks. So I've looked at the unique values in the array, and I see there are some. Everything is treated here as a string. You can see that by the quotes, and there was a question mark. So when pandas tried to read it in, it didn't recognize them all as floats. Oh. We have to tell it something represents a missing values.
Oh. Cursed missing values.
Yes.
It's the curse of data analysis.
Yes, and here we only have a few, but of course most data has a lot of missing values. So that's not a problem. If we know what how missing values are represented, we can give it a set of possible missing value strings. And now we see it actually is represented as a float, because when I compute its sum, it gives me a number. Whereas earlier, if they were all strings, the sum would be a string, of course.
So when you do the sum, it skips over the missing values?
Well, so actually, no, this one, I've reread it in with the missing values.
I see.
And if we look at horsepower, this will now be a float instead of an object.
Oh, I see.
So it removed the rows where there was
Oh, so it removed the rows where there were missing values.
well, it notes the rows, I should say.
I see.
Yes. And when it did the sum, it does skip over them.
Okay.
Yes. So to actually get rid of all the entries with missing values, we can use this drop NA method. And we see that instead of having 397, we get 392 entries.
Okay.
So that means there were 5 rows that had a question mark. And
so in this case, it was reasonable just to drop the rows with missing values.
Yes, only 5 were affected.
Yeah.
Okay, so a few things we'll want to do is often we'll want to select columns of a data frame and rows of a data frame. So we can find the columns by looking at the columns method. And well, there are several ways to index data in a data frame. If we only want the first 3, this is an example of using the slice notation in R. :3 gives us the first 3 entries, the first 3 rows of the data frame, and these are them. You can also, if you have a test, if you want to find all cars that were created after 1980, you can make this Boolean vector, and selecting with a Boolean vector will give you all the cars that were created after 1980. Okay. Now, rows and columns are also, we'll sometimes want to select both, and let me just get rid of this. This is annoyingly big. Okay, for several columns, if we give a list of columns, this will give us a new data frame with only those 2 columns. And there are actually quite a few examples here of indexing that it's important. I think you go through many of them, but we won't go through all of them. I want to wrap up this topic on data frames by talking about plotting from a data frame. So when we have variables in a data frame, I'm just going to move on to the plotting part. And as you see, there is a lot of content in the labs that we won't be able to get through in these videos, and it's important that you follow through when doing the homeworks. Okay. So
this first lab is also intended for people who don't know Python, and so they'll be learning Python for the first time. And so, is it necessary? It's necessary for them to go through a lot of
yes. This is
things.
a longer lab than several of the other ones, and that's because this is the first lab. Okay, so suppose we want to plot. Just this last little example here shows how data frames are sort of aware of self-aware in terms of plot. So that is, a data frame has a plotting method. So first. Well, we might want to, there are columns called horsepower and MPG in the auto, and we might think we could just plot them by using the plot method. Of course, there's nothing called horsepower, so the computer's going to complain, and there's nothing called miles per gallon. It will say, we'll get an error. This is an example of what Python shows you when you run code that gives an invalid output. It's called an exception, and it rightly says there's no variable called horsepower. There is a column called horsepower in auto, and so we can, if we do the following, this will give us the horsepower values. That will be easy to find, and the MPG values, and we can make a scatter plot. Okay, but data frames, as I said, actually know something about how to make a plot. So instead of directly plotting to the axis, you can call the plot method of a data frame. And so here we can make that same scatter plot using the plot.scatter method. And let's just run this. And what axis returned is an axis like the axe we saw when we made the plots above. So we can set the title of the axis, we could set the X label, we could do all the other things we do to a regular axis. But for plotting certain things from a data frame, the data frame can often help us out.